Yes. Good morning, everyone. Uh, so just mic check if I am clearly audible to you because today I am using a different headphone. Anyone, please at least respond to chat. I am enabling the mic as well. Okay. Thank you, Ravi. Hmm. So mic is also enabled. In case you are having any issue, just let me know. So in the last session, we have gone through data centers as what exactly is data center and the basics of data center, the various terminologies related to data center. We have seen about the I, we have seen about the power as how exactly tentatively a power estimation can be calculated whenever a data center plan is there. Later on, we have gone through the cooling aspect as through cooling, how exactly what are the various ways cooling can be maintained, and because heat is one of the major issue as far as data center is being concerned. So we have seen about the cold aisle and hot aisle as a containment where your cold aisle will be isolating the front area of the racks, while the hot aisle will be isolating the back area from where the air is exactly blown. So, uh, mm, this was the thing. And apart from that, there was one more terminology we have seen that was gray area or gray space and the white space, which was designating as Uh, something that is being used by the IT equipment will be called as white space, and all other things will be termed as, or all other area will be termed as gray space, right? So, uh, this was the case. And apart from that, we have gone through the concepts of pods, as what exactly we mean by pod. And if you recall, then we have gone through various kind of arrangements as far as racks are being considered and have seen that how racks are being placed. Ultimately, that decides on what exactly is pod. Okay. Now, coming to data center network, as how and what are the basic terminologies related to data center. So we don't have to go in much of the depth, but at least what exactly is the strategy usually followed whenever data center is there and the various terminologies related to data center network, right? So you can have an estimation based on your knowledge. The way are you saying something?
Not. I have one query from last session actually.
Yeah, right.
There was a discussion point where data center design was discussed, like whether it is a plain ground floor. The entire DC is in the ground floor, and then there was a design, especially in India, there is a multi-story design.
Yes, yes.
So I just wanted to understand: is there any particular impact on this design, or these are because what I understand is because in countries like India, where the space is quite getting space is quite crucial. So the design is like then DCs are mostly the multi-story design. Like in our data center also, they control us. They
Yeah.
mostly they are all building multi-stories, right? Then but is there any particular reason having that, or is just a reason that because of this space crunch we are building it?
No, but I don't think in India we are having these crisis. And only Yota, they means I have seen them as the data centers, those who are multi-stacked into these multi-story buildings.
No,
So,
everyone, even Airtel, even like I said, the controllers
mhm,
entity, like then there are all the STT and all. Then all they all are having a multi-story data center in India. Even in one of the data center in I see Netherlands and Dubai also. Uh,
mhm.
ST Telemedia, they also have a multi-story data center.
Okay. So based on last session, I contacted one of the Yota person as
Uh,
what exactly may be the reason. So
mm,
their point was that earlier, uh, when these government norms were not so stringent,
mm,
right? So that time they used to operate it from different countries only, rather
mm,
than specific to any countries. But now
mm,
with the government norms, they have to manage somehow. But at the same time, they are having a fear because policies usually keep on changing.
mm,
So the point is that unless they will be getting a kind of assurance from the government side that okay somehow uh, the investment will pay out or
mm.
some leaves or some commitment can be guaranteed, you can assume that companies will not be investing this much
Mm.
because investing for data center will be a huge investment.
Correct, correct. Most of the
Yeah.
company like in Microsoft, Amazon, here in India, if you see the
Mhm.
central region and the Southeast Asia region, these are all ideally they are not they are owned by them, but they
Okay,
are
okay.
actually deployed into the Tata Telecom data centers.
Okay, okay. Yes.
So
So
I
main,
internally checked on the within our company like controllers. So what they said is having multi-story is like one of the reason that when because if you hear like tier one, tier two, tier four, highest is the tier four data center. So
yeah,
just to avoid because uh, when they are building the multi-story, they on the ground floor they don't. Keep any of these racks and all just to
okay.
ensure that anytime if there are any disaster natural disaster or calamity happen like flooding and all, so
Mhm.
that's the reason in a specific India region or Southeast Asia region they are building in a multi-story. But I remember in last discussion in there was some sort of power related discussion also happened because I mean I'm not exactly recalling that. So that's why I
Mhm.
asked this. Is there any particular
Uh,
reason in that, or just in government norms, or just like I said, one of the reason to avoid any natural calamity and all?
no, multi-story, I don't think means logically if we try to draw the inference, then
Mm.
multi-story will not be having any impact on power side.
Mm.
Because rather I would feel that if we are
Power
going
or
for
cooling somewhere, I am not exactly recalling actually. I think you're having some discussion on that point.
related to multi-story,
Yes, yes, yes.
okay. No, but again, the point is if you are having the data center that are traditional data centers, that way the airflow that can be maintained within the warehouse sized data center. I think
Mhm.
there you can properly manage the airflows rather than the multi-story uh,
Mm.
data centers.
Okay. Okay.
So still, we'll see that what
I'll also check
exactly
in.
is the
I
case.
was just trying to understand that because
Yeah, yeah,
I'll also check it.
okay. So data center network, you are aware of the basic network, but in case of data center networks, the thing is First of all, it should be uninterrupted in all the cases because it is a data center and ultimately you are housing a lot of servers, right? And those servers may belong to the corporates having their application hosted on the server. And for that reason, what is usually being done is whatever be the internet that is being maintained. So down the line, they usually work with say it be two, three providers, right? So and the supply of the internet, whatever they are having, so down the line they will be having two, three providers, and the parallel internet connection will be there. So they may not be utilizing all of the connections at a time, but the thing is, there will be some ISP is there, and that ISP has ultimately connected to two, three providers. Say it be if you are saying that okay, BSNL, Tata, and say it be any other provider is there. Okay, and so all these connections will be there with your ISP, or and apparently any one of this line will be used uh, at a time. But once a particular connection is down, without any delay, the another connection will put up, right? So that is the main idea behind data center networking, where you should get uninterrupted internet. Not only this, you need to check about the scalability as how scalable the bandwidth is. Okay, so you may be capable enough in terms of servers as what exactly is the server capacity, and you may be having a lot of servers, yon servers. Your servers themselves are capable enough of scaling, right? So not only the server are capable enough, but they can auto scale with that of the load balancers, right? So load balancers can be used, and through the use of auto scaling, you can balance the load to different servers, right? So the account that is being created corresponding to AWS Academy, that is having one experiment related to load balancer and auto scaling. Okay. So the point here is your infrastructure may be capable enough of handling all these things in a proper way. But what if your bandwidth itself, uh, the internet bandwidth, is not sufficient enough uh, to bear the load that is there? Again, taking the example of IRCTC. So during Tatkal hours, say it be at 10 and 11. So the load is unpredictable, and based on the occasion, based on the vacations, the load varies. Okay, and again, even when your server infrastructure is capable enough, but at the same time, your network should also be capable enough of handling those many requests. Otherwise, the request will be dropped at the network point itself, right? And this may create a bottleneck. Okay, so it's not only the core hardware infrastructure that you should bother about whenever you are having some infrastructure setup, but at the same time, you should be sure enough as what exactly will be the bandwidth required by you, And as such, data center always they will be having 1:1 bandwidth. But just for your information, there is a terminology uh, where what exactly 1:1, 1:2, and 1:4, these kind of ratios are there. Not exactly ratio. You can say that 1:1 in the sense that whatever be the line laid down. So through that means you are having a dedicated lead line, and ultimately you will be getting the whole network bandwidth that is being available through that particular link. 1:2 in the sense that okay, two customers may be having, and if the another one is not utilizing, then you may be getting the full bandwidth. So that way, this kind of terminology is being there. So data center usage, it can be compute intensive, it can be data intensive, or it can be balanced. So again, this may be the criteria whenever you are utilizing some data center networking or planning the data center networking, whether the traffic or whether the processes that are being carried out. So this is very difficult to assume, this is very difficult to predict that what exactly will be the case until unless you are having very clear definitions corresponding to the usage of your data center, right? So if primarily you are going to use it as a database server, or if you are sure that okay, most of the servers will be used towards databases and data intensive activities will be there. So in that case, appropriately, you should be framing it as per that requirement only. If it is compute intensive, then apparently, uh, accordingly, the bandwidth and the rest of the things will be chosen. And finally, the balanced one. I hope you are getting the thing because if it is compute intensive, so there are fair chances that mainly your processor will be occupied, right? And yeah, so heavily loaded server, but low inter-server communication. Right? So if it is compute intensive, then you can imagine that processor will be loaded to process to execute the things. Maybe the case with the requirement of data, and because servers are there, then again everything will be at the same place. So inter-server communication may not be that heavy when you are having compute intensive processes. So accordingly, you may take the decision about the bandwidth and the overall topology that you will be having corresponding to the data center. Second is data intensive. Again, because it is data intensive, then definitely there will be huge data center network data transfer, and the load on the servers will be less. So this is one more criteria based on which the decision can be taken. Okay. So racks again, this is what I told you, that ultimately access switches will be required, and 1 Gbps, 10 Gbps. So the speed that is being expected in Gbps rather than what we usually do at our home network, right? So aggregation core switches, this we will see further in detail. So these are the basic requirements corresponding to data center, where it should be scalable, secure, shared, in the sense that okay, if you are having multi-site, so in that case, that network can be shared, standardized, and simplified. So these are the basic requirements. So this will be the case. Racks, again, you are having, you can see that this is 19-inch shelf, and apparently switches will be there. And again, cabling, within cable, we are having the Ethernet cable and fiber cable, right? This we have already seen. Apart from this, routers, switches, routers will be used. But again, apparently it will be planted within these uh, racks only. You can see the cabling over here. So structured cabling is there, and even they are having the tags, right? So you yourself might have seen. So what is exactly happens is, suppose this is the terminal, and apparently this cable is going somewhere. Okay, and now we need to check whether there is any issue with the cable. So this is one case. There may be several cables coming over here. So how exactly you will be differentiating, uh, or how exactly you will be identifying that a specific cable uh, in this particular area? So what happens is, usually these are being tagged. These kind of tags are there on the cable, and say it be some kind of number maybe there, say it be 112. Okay, so here also we will be having the same number, uh, and that way we can identify that, okay, if it is 112 over here, then definitely at the other end we have to look for the same number 112, so that uh, we can use a cable tester or some another tool through which we can check the continuity and whether the cable is intact or not. Okay, so this is the main structure usually followed by the data center. So just have a look. So till now we have seen a lot of rooms as far as data center infrastructure is being considered. Okay. So now you can see that, okay, there is main distribution area. Then you are having horizontal distribution area, that is HDA. Then zone distribution area in some cases, and the EDA, that is equipment distribution area. So all these are the different levels that are being maintained within the data center. Just right. So within this, you can see that, okay, there is a core mentioned over here. Then there is some terminology known as TOR and EOR, that is top of rack and end of row. I think we have discussed it. There is some more detailing about this as well, right? So this is main distribution area, then horizontal distribution area, and finally the equipment distribution area. So the main idea here is to distribute the traffic effectively, so that the whole traffic should not be borne by a single switch or single router. So effectively, if we are able to divert the traffic to different switches based on their capabilities. Say it be 48 port switch or say it be 96 port switch. So accordingly, these areas are being defined. So main distribution area, you can consider this main distribution area as the central point where you can see that the incoming internet and power services will be there. So the main distribution area will be having, say, you may say that, okay, the fiber that is coming corresponding to the internet service provider, so that will be coming to the main distribution area. So your switches will be uh, accordingly chosen that can have the connections through the fiber networks. Okay. Apart from that horizontal distribution area, so we need some immediate or intermediate point for the data center cabling pathways. So that you can consider as a horizontal distribution area. The point again is that okay, internet connection is there, and corresponding to this internet connection, now you have to distribute it to different areas of your data center based on the capability of the switches and the routers. Okay. So if it is a 48 port switch, so ultimately the maximum connection that you will be able to extend out of it is somewhat 46 or so, because one will be the one may be the uplink, and rest you will be utilizing, and maybe the case that if that switch is being connected to some another switch, so one port will be utilized over there, right? So that's why I'm saying that okay, 46 ports can you can use effectively. It all depends whether you are using the uplink or not. Equipment distribution area. So this you can say that it is a space within the data center where networking equipment, uh, then switches, routers, and all will be located specifically that are being connected with the endpoint, say it be the servers, say it be the storage devices, and all. So I think these three are having clear definition where the main distribution area is something where we are getting the connection, fiber connection, and ultimately through main distribution area for better distribution and not directly connecting it to the end devices, we are utilizing the layer that is HDA as the horizontal distribution area. And finally, through EDA, that is equipment distribution area, it will be connected to the service. There is one more entity, if you see the left, that is zone distribution area. You can say that zone distribution area is a localized distribution point within a data center, and that will be serving a particular zone or area, right? Uh, and the main difference with that of other combination and this one is that supposedly if a specific device, a specific networking device is being required uh, to this particular area. So in that case, we may be defining one more hierarchy within this particular configuration, and that is your zone distribution area. Uh, Not to complicate, you can say that okay, you are adding one more hierarchy based on the requirement of a specific device, right? So in that case, it may be having one more level, that is zone distribution area, right? So mainly the standard that is being associated with data center networking is ANSI PIE 942.2.0.5. This is the basic standard that specifies how cabling should be done, what kind of switches should be used in terms of configuration and all. So these are few of the listing as what should be the distribution areas, uh, how you should be defining the various rooms. So, and again, the zone distribution area, somewhat optional in nature. Apart from that, definitely cabling will be done. In this diagram, you can see that there are two terminologies. One is backbone cabling, and another one is horizontal cabling, right? So, again, there is one concept known as east-west traffic and north-south traffic, so that we will be having a look. There, this backbone and horizontal cabling will be utilized. So this is the case. So this is the core, and core you can say that it will be part of your main distribution area, and this is your right. So this is a common combination that may be there. Based on the requirements, there may be the case that you are utilizing some more high-end switches, but this is just to give you an example that okay, the core can be a 100 to 400 gigabit switch, and this is a 10 gig switch, and edge you can have some common switches connected so that the servers are connected with those switches. Again, this is you will be having 1 Gbps at least that will be required even at the edge. What the area specifically will be called as MDA and HDA, while logically when networking terminology is being utilized and you have to define a layer, then this is your core layer, this is your aggregation layer, and finally you are having the edge, that is the racks. Okay. So here you are having the terminology TOR, that is top of rack. So it's about hierarchical networking that we have seen. Ultimately, it will be maintained in the hierarchy and somewhat similar to that of the area. That area may be resembling what a specific layer will be delivering. Okay, so core layer, you can just have a look that it is high speed switching backplane and will be responsible for the connection with the external internet service provider, right? And the protocols that are being utilized uh, for having the connections and all, that is the OSPF, right? And apart from that, the switches that will be utilized over here will be some high-end switches. Similar way, aggregation we already have seen, but the switches here will be the layer 2 switches so that it can be manageable. And finally, the access layer. This rack versus blade server we already have seen. Aggregation, okay, we can avoid this. So these are few of the design goals. just have a look, and challenges as well. Just go through it. I think it is quite obvious. So availability and fault tolerance, uh, then scalability, low cost. So this may not be the case in all the way that uh, few of the companies may not be having this as a parameter or a design good. Throughput, economies of scale, right? That is utilizes the benefit of the huge size and scalable interconnect bandwidth, and finally the load balancing. In a similar way, you will be having few challenges with reference to data center networking, that is reduced utilization, scale out versus scale up, right? Again, taking the example of IRCTC, so it's not only about the capability of the server, but in bandwidth also you should not be overestimating something, or you should not be having some underutilized calculation corresponding to the bandwidth, right? So that way you should be able to make a decision that okay, the resources or the bandwidth that is being required should not be much more than 10, 20% or 30% of the overall highest that is being going, right? And placement of placement of the switches. So again, that is one of the major challenge, because the way you will be placing the switches will be deciding how uh, the overall network is laid down within the data center, how the airflow rack density is being there, then resource fragmentation, that is virtual LAN that are being created nowadays. So even when you are having a 48 port switch, and supposedly you would like to isolate uh, it as two 24 port switches. So ultimately, you are creating two virtual LANs, and now this will be your completely virtual 24 port switch. Why we are calling it as virtual? Again, you may be having a thought that when 24 physical ports are there, then why we are calling it as virtual? Because of the basic definition of virtualization that says that it is not what it is pretending to be. Right? So what exactly is the case? In actual, it is a 48 port switch, but it is pretending to be a 24 port switch because of the VLAN that is being created, and that's why we are calling, or we are utilizing the terminology virtualization, because it is not what it is pretending to be. Okay. Mm, configuration over subscription. This 1:1 versus 1:240. This we have already discussed, but this is not a challenge in the sense that nowadays all the ISPs, so even if you are having an office or corporate, so that way they are capable enough of delivering 1:1 line that is dedicated to you. So now the infrastructure has been laid down. So as of now, it's not a challenge. And obviously, what Ravi have mentioned, that flooding, routing, uh, networking, overhead. So this will be the case. Now the location of switch. Okay, so I think we have discussed it, but just have an idea. Top of rack, as the name suggests, you may be deploying a methodology where all the networking switches related to the servers utilizing within the rack will be there at the top of the rack. Okay, and there may be a topology where you may be having all the servers within the rack, right? And your switches may be at the end of the row, right? So the switches may be at the end of the row in the sense that there may be a single rack that is having all the switches. So that rack may be having nothing else apart from switches. So only switches may be there. Okay.
Sir, I
And
have one question.
yes, Gautam.
Yeah, so in some of the pictures we saw that from the rack servers connections or the connecting wires goes outside downwards. If the switches are top, why don't the connection goes up first from switches to server?
Mm, here in top of rack.
Yes, top of the rack.
So top of the rack in the sense that okay, if this is your rack and here you are having the server deployed, here your switch is in there. So ultimately the cabling will be done from this to this. If another
Okay.
server is there, yeah. So
Yeah.
we don't need any connection to be laid down within the race flow. But here what is the case is now we need to have the connection or the cabling to reach to this location, right?
Mm-hmm.
So ultimately either I can lay down it through the roof
Because
or
this will be connected to next aggregation switches because uplinks forwarding to the aggregation switches. So that's why these access switches are at the top of the layer because servers would be considered as the S servers, S devices.
yeah, agreed. But the thing is, both of the methodology can be utilized. Means it's
Yes,
not,
yes.
yeah. So it all
These are
depends on.
generally in top of rack align. This setup is generally used in the data center environment, where there are so many racks are there, right? And then this below setup, what I have seen in my experience, these
Mhm.
are generally the in-house data center wherever any company have in-house data center, a small data center, no. Uh,
Yeah,
this setup I have seen most of that environment. But in enterprise level, big hyperscalers, the top of rack is the one ideal setup which is I have seen.
yes, obviously. And you can have several other inferences out of it. Say it be, there is a requirement where you don't have much of the budget for having
Yeah.
more number of networking people,
Yes. Yes. Yes.
right?
Correct.
So in that case, what you would prefer, top of the rack or end of the row?
Even from the scaling perspective, also the top of rack is what it is a kind of you bring the one rack with all the servers and the top of rack switch, and you just have to plug into the aggregation layer. That's it. So
Yes,
that is
yes.
also another
That is, yes.
way of
From that
looking.
deployment perspective is also good. But as you said that in few of the scenarios where what we can say that just like the question that I have raised, if we are having a limited budget for the networking personnel, so in that case, end of the row will be more preferable because few people will be able to handle the whole networking in that case. In case we are having top of the rack, so in such way, I will be needing people to be available to different racks or at least the rows so that they can handle the networking part.
So, but in
Just to
case of long cable, in case of long cable, so will end of rack is beneficial here?
Yeah, obviously, in end of a row, it will be needing more cabling rather than that of the top of rack.
Mm-hmm.
But again, that is a one-time cost. If you see, end of the row will be one in that cabling will be one-time cost. Once you have spent on the cabling, after that you don't have to put the recurring cost for the salary of the networking personnel that much. Say it way, if in a normal case, top of the rack, if you are good to go with 5 to 6 networking personnel, so in end of the row, there may be the cases that you would be able to cover it up with less number of networking people. And overall, if you go with the TOC, uh, TCO, sorry, total cost of ownership, so ultimately that may be a viable solution. But it all depends on the need.
So
I think
that
But
means,
the second, yeah, sorry.
yeah,
yeah, so that means in end of the rack, only one switch is serving the multiple racks, in my understanding.
not
While in the
one
top
switch,
of the,
but there may be multiple racks based on the number of servers. So,
okay,
yes,
It's a kind of
okay,
network rack actually. It's a kind of network rack end of the switch, the below
yes,
the
yes, you can consider it as a network rack. So, corresponding
particularly
to
that
that
will
rack, only switches will be there. And
correct.
if requirement is there, there may be another rack again that is having the switches. But the main idea is ultimately we will be isolating the servers and the switches will be mostly be placed in a specific rack rather than having a mixture of servers and your this networking switches. Okay.
And it has like less number of network equipment and manageability. Like you don't need to manage more switches and all.
Yes.
That is from scaling perspective also, sir. If I'm not wrong, the second diagram is having a challenge, right? It has a limitation on the scaling
Mm,
because that's where I said is because in a small environment generally this is the approach generally followed
yes,
because
yes.
yes,
Yes.
yes.
So end of the row will be followed mainly in small setup.
small
Even
setup. Yeah.
higher latency will be there in end of the rack as
Because
compared
Yeah.
to the
the long cable
top
is
of the
going,
rack.
it will be also a latency here. Yes.
Obviously, latency will also increase a bit, but will be there. Latency will be there. But again, we should know the option that what exactly are the options. So that's why end of the row is one of the options that we can go. So I think we have pointed out all the cases. Top of the rack cabling will be somewhat easier because it is within that rack. And if the rack is not fully populated, so we can use those top of the rack ports as well. And the only problem is if rack traffic demand is high, difficult to add more ports in the sense that, but I think that will never be the case in actual. Say it be if you are having servers and apparently altogether the number of servers are more. and you exhaust with the number of ports you are having within that particular rack. Okay? So uh, again, that particular issue needs to be handled. Say if you are having 24, or say you are having 42 rack, and within that 42 rack, say uh, just for an example, corresponding to that 42 U rack, and there are two U servers, and supposedly you are having 20 two U servers. So this will occupy 40 U, and the two units will be remaining. Okay, and supposedly we are having a 24 port switch. Right? So what I mean to say is there may be a situation where you are having number of servers more than that of the number of ports you are having corresponding to your switch. So in that case, adding a port will be somewhat difficult. All right. So either you have to move the server, or uh, you need to change the switch configuration, or you need to change the switch. Right. So it may be the case, and this is one of the drawbacks, because here if I am having end of the row, so I'm having lots of switches where any of the port corresponding to that switch can be utilized, right? But here in top of the rack, ultimately I should be having the port within the top of the rack only, and if not available, then we have to find out the way for it. End of the row, definitely just like Jyoti have pointed out, that longer cables will be there. Server, but the thing is that server can be placed in any rack, and ports are easily added, upgraded in end of the row configuration. Yeah. These are the basic topology where you can have the fixed, flexible. um, Apart from this, whenever networking is being seen in terms of data center, there is a terminology known as east-west and north-south traffic, because you should be peculiar about what exactly will be the case in order to plan the data center and what exactly is happening once the data center is in operation, right? So I think by the name itself, you may be able to figure it out what exactly we mean by east, west, and north, south traffic. Whenever we draw the direction, it is usually like this, that east, west is somewhat kept horizontal in ideal most of the cases, and north, south is somewhat this vertical, right? And if we see the data center in the sense that, okay, this is my data center network, and, and these are the switches having the hierarchy, and this is the internet connection that is coming. So apparently you can see that we are pretending this to be north south, and we are pretending this to be east west. So I think now you will never forget the concept that whenever internal server to server communication is being there, so that will be your east west traffic, and whenever you are having the communication from outside the data center, so that is usually called as uh, north south traffic. Why this is important? Again, the case is for better network planning, we should be sure enough as what exactly will be the communication between the server to server, whether it is data intensive, whether it is compute intensive. So that particular case we have seen. So currently you can think of, and accordingly the planning should be done. Right? So network traffic. It can be characterized into north-south and east-west. So whatever be the data packets that are being floated from server to server within the data center, that will contribute towards east-west traffic. And inspired by network diagram, ultimately that depicts local area, obviously. Okay. And again, when you are having some data intensive or compute intensive, accordingly, the east-west traffic will vary. North-south, whenever we are having client-to-server communication or traffic from outside the network is being there, that is usually being called as north-south traffic. So rather than deep processing, if you are having some web servers also, so the web servers are usually will be having more net north-south traffic rather than that of east-west traffic. Until unless the website that is being hosted needs lot of internal processing to be done. Till that time, in most of the cases, it will be north-south traffic. So web browsing, email, and some cloud-based applications that needs lot of client interaction will be part of the north-south traffic. Okay, and obviously with the use of cloud computing, this north-south traffic is increasing a lot, and we are relying accordingly. We should vary the bandwidth as well. Right. So last topic corresponding to data center networking. Ultimately, uh, link aggregation will be required. We are having a lot of connections that are being laid down through the switches. So ultimately, how exactly uh, the aggregation will happen for better utilization of the networking resources, right? So just see link aggregation. You can say that it is also termed as port trunking, channel bonding, and also nomenclated as NIC teaming. Okay, so it is utilized ultimately within Ethernet, right? And it will combine the multiple physical links between two networking devices into a single logical virtual link, right? So that means you will be combining it, and then the networking traffic will be laid down through this virtual link. And by virtual link, again, we mean that somehow with the logic of link aggregation, you are combining it, and at a later stage, when the transmission is complete, you are able to uh, separate the content or separate the packets that are being laid down to through those two links separately, right? So that can be done. The connection, whatever be the devices we are having, so it can be the switches, switch to server, or it can be switches to NAS, that is network attached storage, or switch to access point. So any of this would be possible. Okay. Why we are going for the aggregation? This main reason will be the fault tolerance, that by having the aggregation, we will be utilizing uh, fault tolerance. It can have a link redundancy, and obviously we will be increasing the bandwidth once we are able to achieve link aggregation, right? So two types are there. Excuse me. So static link aggregation and dynamic link aggregation, these are the two things. In dynamic aggregation, it will be carried out through a protocol. Excuse me. So dynamic link aggregation will be carried out through a protocol known as link aggregation control protocol, that is LACP. And your static link aggregation involves manual process, and switches needs to be configured ultimately to form a link aggregation group. Okay, but here in case of dynamic, it will happen. Means you can have the groups, and apparently all those ports can be automatically form a link aggregation group, because the switches are utilizing the protocol LACP, and utilizing this protocol, the switches are smart enough to have the dynamic link aggregation. Right. So just have a look. It's an IEEE 802.3 protocol, and in this we have already seen that it will bundle multiple physical ports and will be having a single line. So we'll quickly see the difference. So I think you might have got the difference, whatever we are having between the static and dynamic link aggregation. More or less, we will be having the difference with LAG, link aggregation group, and link aggregation configuration protocol. So this is a logical link that will be established within the static link aggregation, while LACP is the protocol that is being utilized by the switches so that they can dynamically achieve the link aggregation. As far as function is being considered, here we are bundling the multiple links, and here dynamic link aggregation is carried out through this link aggregation configuration protocol, right? Here it can be manual or automatic configuration, but here because LACP is being utilized, so it will be uh, automatically negotiated and dynamic in nature, right? It can be used with or without LACP, that link aggregation group, but here in LACP, because it is a protocol, so that's why you will be requiring LACP in case you would be going for a dynamic link aggregation. This way you can go through the differences. Um, Now coming to, we will be going to next module, that is virtualization and containers. I'm having a bad throat, so just give me some time. We will have a 3 minute break, and then we'll continue.
Yeah.
resources delay. So now we will be going through the concept of virtualization, containerization, then virtual data center, um, cluster, virtual cluster. All these things will be there. Initially, we will go through the basic difference between virtualization and container, and we will see one experiment related to Docker. So I'll demonstrate as how exactly we can create a container image and how we can utilize it by forming a container. Okay, so why exactly we will be needing the concept of container? So the main reason is whatever be the drawbacks of virtualization. So those drawbacks of virtualizations are being mitigated utilizing the concept of containers, right? So we will see that this is a standard machine having infrastructure, host, and the libraries corresponding to the application. So though that application is having utilizing the library. So this may be the other case where we are having virtual machine. Okay? So the infrastructure is there, host operating system is there, hypervisor is there. So as an example, you can say uh, here you are having the computer hardware, then the operating system may be you can say Ubuntu 24.04 and you may be having some hypervisor, say the Oracle VirtualBox or say the Hyper-V, right? So apparently some hypervisor will be there. And once you install hypervisor, then you will be able to create virtual machines. The only thing is your hardware should be supporting virtualization, and not only that, your hardware should be enough in terms of capacity so that virtualization can be enabled. In the sense that if you are having 32 GB of RAM, okay, then only you can think of at least this kind of configuration because you can expect that 8 GB of RAM will be required at least for your host OS. Or if you are thinking other way around that, okay, 16 GB will be required for the host OS. So in that case, the virtual machines may be allocated the rest of the 16 GB RAM, say it be 4 and 8 GB can be allocated to the virtual machine. But the thing is, corresponding to a virtual machine, we are having the guest OS in all the cases. Say it be for application A, corresponding libraries are there. So these three virtual machines may be carrying out different operating systems as well. Say it be virtual machine 3 may be having the Red Hat, virtual machine 2 may be having some another operating system, say it be CentOS, and the virtual machine 1 may be having the Windows operating system, right? So this may be the case, and this configuration is utilizing ultimately the concept of virtualization. Now see the difference as compared to the container concept, where rather than hypervisor, now we are utilizing a Docker engine that supports the concept of containers. And if you see, then now guest OS is not there. Okay, so only your application is there, and the corresponding libraries are there that needs to be carried out. What does it mean? Say it be if I'm having some Python application, so corresponding to that Python application, only that Python application and respective libraries, those libraries will be utilized and a container image can be formed, right? And once this image is being ready, just imagine how easy it would be to scale and how easy it would be to migrate from one location to another location, because here just imagine that a complete guest OS is being required, while here because operating system is not at all involved, only your application and the respective library utilized by the applications are there. So that way it is very lightweight in nature. So if you talk about scalability, if you talk about what we can say, the appearance, in the sense that supposedly if I have to uh, get 20, 30 instances quickly, so that way rather than virtual machines, we will ever prefer containers, because putting up 20 containers and putting up 20 virtual machines will be a different case as far as the time is being considered. Not only this, whenever we need to scale further or transfer the container image from one server to another server, then also containers will be a lightweight solution as compared to the virtual machine. Definitely, there are some drawbacks, but still, container will be the preferable solution in most of the cases, right? So this is the case. Application A, corresponding libraries are there. There may be a case that, okay, application B and C are not having their libraries or the overall system that is there. So application B and C may not be having the respective libraries. Okay, here that particular problem we have solved by the virtual machine. So now guest OS are there, and corresponding to guest OS, apparently different guest OS may be carrying out different libraries, and you can run the programs accordingly. Say it be if something is specific to Red Hat, CentOS, or Windows. So accordingly, the libraries can be utilized, and all those applications can work. Okay. The only thing over here is that the guest operating system occupies more space, and definitely there will be some performance bottleneck. But in case of container, uh, you will be finding it efficient and portable as well, because uh, it's only having the application and libraries, and this is the case where it is not having the hypervisor, rather it is having the Docker engine, right? So just uh, have some practical things that, say it be if you are having Apache Tomcat and Java, or if you are having the SQL Server and .NET, Python, MySQL. So all these combinations can be considered, and ultimately you can have it in a lightweight mode, right? And within a single system, you will be having all those deployments. Maybe if you would like to have two different configurations corresponding to the Python. Okay, so say it be 3.9 and 3.11. Supposedly two different versions are required. So rather than having two virtual machines, what you can do is you can utilize two Docker containers And when you use two Docker containers, apparently in any of the containers, when you will be requiring a specific version of Python, you can utilize that particular container. Okay. So why exactly it is being required? Many of you may be using it, so please bear with it. But those who doesn't have, never have used containers, it's really some interesting concept to learn, right? So whenever we are having some software developed, there are a lot of issues as far as the what I can say the configuration is being considered. Okay, so a developer just see the scenario. A developer will set up a JBoss software on his system. So JBoss is your application server, and you can utilize this application server for developing some kind of core, excuse me, some kind of core application logic, right? And once the application is developed, it will be examined by the testing team. So we are having a small team over here, and many times it happens that most of the tasks are being carried out by that team only, right? So in one of the case that we have seen is that we have developed one Python application, and in that we were utilizing the face recognition libraries as well. And apparently, a lot of complicated healthcare logics were implemented within that Python application. So what was the case is altogether the overall size of the application was somewhat 6 GB or so. And when the same team tried to configure it on another system, right? Just try to understand when same team tried to configure the same deployment to another system, it took them 2 days, right? So it was not out of their inefficiency, but the thing is that in terms of Python, the library dependency and figuring out the exact library to be carried out for that particular application. So finding out those libraries, so that was the main challenge uh, because of the complication of face recognition and other things we have put it in. So just imagine that was still an small application, but when some enterprise level applications are being developed, and now the setup is to be done again by the testing team. So how tedious it would be, right? Because in my scenario, when the same team have deployed it, then again they have faced the same the problem. So with developer and tester, there may be a lot of differentiation, and because of that, again they may be facing or they may have to install it again, and installation will consume time, right? Same is the case with once tested, then it will be deployed by the production team. Production is somewhat different. That okay, apparently they have to um, host the Java application, and JBoss needs to be configured. Definitely, that can be done. But just imagine corresponding to a setup, the developer, tester, admin, these three will be majorly required, and apparently all of them will be configuring the application at their end. Okay, so can we make something that can ease out the thing, right? So why the same JBoss installation is done twice? Okay, so the reason, one reason maybe there may be several reasons because obviously Now, whatever the system that developer have used will not be used by the tester, and apparently uh, the setup needs to be done. But the complication can increase when they may be having the different environment, different configuration, and that's why JBoss maybe whenever you will be configuring, so there may be some different configuration rather than that of the developer's configuration that you may have to do, right? So that's why the installation is done separately on the different computers. Okay. So the question arises that this process consumes a lot of time and effort. Can there be alternate ways to do this? So ultimately, what comes out to be solution is the container. Now we will see that how exactly container turns out to be a solution for this particular case. Okay. So Doctor, okay, I think you got an idea as what exactly Docker will be doing. We already have gone through the logic and the need. So ultimately, somewhat similar to that of hypervisor, but having totally different capabilities, where we will be bundling uh, what we can say applications and the libraries on which the application is being dependent on. So a bundle or an image file will be created that can be run over a Docker engine. So the Docker engine will be acting as a layer of abstraction and masking the lower details, say it be the hardware or say it be the operating system. We will see further what exactly is about the operating system dependency and all. But ultimately, once you create a container, after that, you can use that bundle to shift. So the idea is somewhat you can predict it by the name itself. Okay. So whenever we are having shipping, so corresponding to shipping, there is a concept of containers. So in those dockyards, shipyards, ultimately containers, big containers are there, and they travel long miles through the sea. Apparently, the core logic is whatever be the things that are being stuffed within the container, they are being arranged. And once the container is locked, after that it is good to go anywhere, and it will be as is till the destination until unless some turbulence or any other thing happen. But in this is the common concept that is being drawn, and that's why it is being named as container. So once you have that bundle file, after that you don't have to worry about the libraries, you don't have to worry about the dependencies. So all things will be taken care by the Docker engine, because altogether you already have uh, bundled the application and the libraries, right? So this is the main thing. Okay, we'll first see the concept and then so as far as history is being considered, specifically about Docker, containerization is a generic concept, but mainly carried out through Docker. Okay, so it was originally created by Solomon Hike and from dot cloud, and later on it was named as Docker. It's an open source project, but apparently some enterprise edition is also available. They also have released the community edition so that you can seamlessly using it. Now, Docker 5, right? So all the time I was naming you that some kind of bundle will be created. Okay. So the technical nomenclature for that bundle of application and your uh, library. So that bundle is your Docker file. Okay. So Docker builds images automatically by reading the instructions from the Docker file. Okay. And ultimately it is a text file that contains so Docker file application. Yeah. I need to correct this. Docker file will be the file that we will be referring, and application plus library bean. This will be your Docker image, right? So I'll make it clear as what exactly is your Docker file. Docker file is the reference document that will be read, and apparently by following the instructions mentioned in the Docker file, ultimately Docker engine will be creating Docker image, right? So it's just analogous to that of instruction manual. So suppose you got a new gadget, so what you usually do, just to configure or just to assemble it, you usually follow the instruction manual. You go through the step-by-step process specified in the instruction manual. You assemble it or you configure it, and finally start using it. Same is the concept over here, where you will be utilizing the instructions mentioned in the Docker file. Uh, so the Docker engine will be utilizing it and apparently creating a Docker image that will consist of the applications and library bin. So usually you will be finding templates corresponding to different requirements with reference to Docker files. Say it be if you would like to have some Python, and say it be you may be needing it for Node.js. So corresponding to the environment for which you would like to create a Docker file, so you can get this template, change the variable, say it be the HTTPD is here, Apache server. Okay. Uh, Rest you will be having few other entities, and you can just see that what this Docker file is doing. Can anyone just go through the Docker file and predict that what exactly will happen when the instructions given in the Docker file will be utilized and a Docker image will be created? So what exactly that image will be done? Yes, anyone?
So from HTTP, it will be downloading and installing the web server, HTTP server,
Correct.
and then it will label it whatever the author and version we are giving it, and
Right.
then from local drive it will copy the MyPage file under the HTTP docs, which will be inside the image.
Yes. Correct. So, so what Ravi has said is correct, that apparently from HTTPD, this will be the instruction for installation, that okay. Apache with a specific version will be installed. Appropriate labeling will be done. This is comments. So these will be your comments. And you may be saying that, okay, copy. So my page, you may be thinking that what exactly about the location and all. So this will be relative to that of the file location. Say it be the Docker file. Okay. So wherever Docker file is there, if it is on the same location, then you don't have to give any folder and all. Otherwise, you just have to give the relative location with reference to the Docker file. And this is htdocs slash mypage.html. So within HTTPD, when you will be configuring, so there you will be having a folder named as htdocs. So this page is being copied over there so that now this Docker image is good to load this mypage.html whenever this container image is, whenever you will run and you will be having a container corresponding to this image. So you will be able to load this mypage.html, right? So Docker image, uh, I have already communicated that you will be having a Docker file uh, where the instructions of the Docker file will be followed, and once a build is being done through Docker, okay, so Docker image will be created. So image can be a normal file, right? And you can say that until and unless you put it into a runtime environment, and that runtime environment is your Docker container. So image is what you can say the difference between your program and process. You can have this analogy in this case. So program something stored and process is something in execution. So your Docker image, you can say that a program, but when it is in runtime environment, then you can call it as container, right? So runtime instance of a Docker image and will always run the same regardless of the infrastructure. Okay. We will talk about this more, that what dependency will be there and all that. But the thing is, you don't have to bother about the configuration. Means supposedly I have created some image, and now if I transfer that image to Ravi, what he will be needing is a bare minimum Docker will be required, and once he create a container out of it, so whatever be the image that I have shared, say it be corresponding to loading of some HTML page that we have seen recently. So he don't have to do any configuration. He don't have to install Apache. He don't have to do the labeling. He don't have to copy the file to a specific folder. He just have to execute that Docker image and apparently create a container. And that page will be loaded within that particular container. Definitely some port mapping will be required, but apart from that, uh, you are good to go to execute it. Okay. Docker Hub. So whatever be the images we usually need in general. So though for Docker Hub will be the repository for all those images. Say it be Gautam may be needing some node container, and someone else say may be needing a zookeeper, someone may be needing the setup of Kafka. So if you prefer that rather than doing the core configuration, if you are okay with the basic, uh, what I can say, the Docker image, so that least configuration will be needed. So in that case, Docker Hub will be the repository. Okay, just like your Play Store or App Store. Similarly, whenever you need some readily available Docker containers, sorry, Docker images specifically, because once they put into the runtime environment, then they will be termed as containers. Okay, so this is, you can say that it is a repository of the images. So the life cycle will go like this. State B, you are having some Docker file. Based on that Docker file, you have built the image, and apparently you can execute it. Other way around, you can push it to the registry or the Docker Hub. Someone who requires that, okay, may pull it from the registry and hub, and can utilize that and execute it, and the container will be utilized for that. Okay. So it's done. So I'll quickly, right. So in Windows, you are having Liberty, where you can download Docker Desktop. So that way, your engine will be there, and that's why the central screen it was showing that starting the Docker engine. Okay, so now you can see images. So three images are there as of now. One is Hello World 1511 and Zookeeper and Kafka. So I was needing Zookeeper and Kafka, so but I was not interested to ultimately do the whole configuration corresponding to Zookeeper, corresponding to Kafka. So what I did is I pulled their images from the Docker Hub repository, and whenever needed, I turn on these containers and apparently use the feature of Zookeeper and Kafka, right? And this the other image that you are having a look, Hello World 1522. So that image is specifically corresponding to one application where one web page will be loaded and uh, you can just have a look to that web page. So these are the images, and you can see that this is local, this is my hub. So right now I haven't connected it. That's why it is showing sign in container. So once something is being made into the runtime environment and appropriate container is being assigned, so that way you can directly run it from the from here. So I'll just open it. Then opening the folder. Now you can just have a look. So here there is a Docker file, and I hope this is visible. Okay. Right. So now you can see that Python 3.9.6 is to be installed. Okay. Then a working directory slash app needs to be defined that okay, an environment variable will be there and set up a working directory in the container. Uh, Within the root, app slash app will be there. Copy requirement.txt to the current directory. Whatever be the working directory, requirement.txt will be copied. Run the requirement.txt. So those who are aware of the Python, you may be knowing it. So whatever be the library dependency that can be mentioned in requirement.txt, and then that dependency may be handled and installed through this pip install. So pip install is the command, and you can see that ultimately we are installing this requirement.txt. Copy dot dot in the sense that whatever is available in the directory where this Docker file is being there, copy all into the working directory. So whatever be the working directory specified, it needs to be copied over there. And finally, the execution that okay, Python 3. So this is the basic command that you will be utilizing for the final execution. So this is the case, means ultimately this is a Docker file through which utilizing this you can build the Docker image. Now you can see the app.py. So app.py, it's a basic index.html page will be rendered, and it will be displayed, and ultimately 8989 port may be utilized for this. Okay?
Here, Flux is the web server, right?
Uh,
The
what is the case?
Flux. What is this Flux here?
Flask.
Yeah,
Yeah, yeah.
FLA
Flask is the web server.
web server. Okay.
Not exactly web server, but you can say that in Python, this is the directly we cannot say that it is a web server, but framework more precisely you can say that Flask is a framework utilized in Python. Means I'm not good at Python, but
Yeah,
I'm just
that's why.
correlating it with
Yeah. I'm also not here.
that
That's
how
why.
exactly we can go through the Python. So supposedly we have to execute in local, so we can run it through Python and then app.py. But this is running in local. The thing is, if you have to run it in local, so this is the case that because we have specified it. So this is the basic thing. Ultimately, this page should be loaded whenever this whole application is being executed, right? So this is the basic idea. Okay. Now, but this is running in local in the sense that whole configuration needs to be done. So now we'll try to build image. Right. So you can just see Docker build hello world. So we'll have today's date, say 1104 and dot. right? So this is the build command through which the image will be built. So as such, we already have seen that till now. Within images, only three images are there: Hello World, 1511, then Zookeeper, and one is related to Kafka. So as soon as we build it, right now you can see it totally happens in 5 stages as far as uh, this Docker file steps are being considered. You can see that 1 out of 5 from docker.io library Python 3.9.6 gets captured and ultimately being installed within the image. So 2 by 5 work directory is being specified as /r. 3 by 5 that is copying of requirement.txt to the current directory. Execution of whatever be the requirement.txt content, uh, whatever be the libraries mentioned in the requirement.txt. And you can see that class is there and there is one more library that is being there. Okay. And later on, you can see that uh, run pip install, the execution instruction is being, sorry, this is the requirement.txt. The libraries are installed and finally everything available over here is being copied to the Docker environment. Okay, now the image will be available. Now you can see that there is it's refreshing. Change the name of the file or num. Okay, I have used the numpad and because of that numlock was off. So the same name that is 1104 was there. Okay, today it is 1104. Sorry. Right, so this is there. Now the Docker file is being created. So you can see that it is created 2 minutes ago. And now this file is there. You can push this file that okay, this file I can send it to Gautam, to Ravi, and apparently what they have to do, they just after pulling it from the location, they just have to execute the command. So Docker run -t. You can specify the port number, and finally you can say that hello world 1104. Okay. So Docker run -d -p -d is for detached mode. That is runs the container. It will run the container in the background, and apparently here we will be getting the container ID only. The main reason for utilizing it is the terminal will be available once we use -d. That is detached mode. Okay. And -p is published. That is, it will publish containers port to host port that we will see. But first of all, we will see what exactly is happening. So right now, if I try to see local 9,000, right? It is not working because right now it's not operational. Even 5,000 again not working because neither we have done the port mapping nor the Docker image is live. Now, as soon as we execute this command docker run -d -p, we have done some port mapping. We will go into the depth as what exactly this mapping is being done. Okay, and we can see that a container ID is being returned. when we will be working in Linux, so at that time this container ID will be of very much use. Now you can see that Docker, you see in container, you are having one new container. Either you can name it or they will name it by themselves. So it is being named as Hopeful Ramanujan. Okay, but it is utilizing Hello World 1104 image, the CPU utilization and all, and finally the port. Now just see that if I will share this Docker image with any one of you, you having this Docker engine or Docker desktop, and you just have to uh, run the container. After that, as soon as you go to the web page, and apparently whatever be the code mapping that was done, and right, it's that easy. It's neither you have to install Python nor you have to install requirement.txt, the libraries that are being there. Okay, so just see that I have done nothing. Means right now, even if you see this VS Code, then that Python application is not running. Ultimately, we just have created the container, and now we are running that Docker container. Okay, even I can close this so that VS Code is closed, and apparently, even if I refresh it, so it will be there because ultimately the container is running. So this is the ease that comes with the concept of container. So whatever be the utility, you can bundle it in one image file. You can share the file, and the other person other way can just have the Docker engine, and apparently once the container is being there, he can utilize the application. Right? We will talk further about the minute details about the container, the various other commands and all, but this is how the concept of container is making the developer's life simple. Yes. Any questions? Okay. In that case, I'll stop over here. And in the next session, we'll be talking in much detail about Docker, not only in terms of the basic deployment, but the minute things, just like the virtualization, the type of virtualization it poses, and all other things. Okay. If nothing is there, then thank you. I'm ending up the meeting.
Thanks.
Sir, can you please share that those PPTs?
Yes, yes. I'll be sharing. Just give me half an hour. I'll be uploading it to Teams.
All right. Yeah. Thank you, sir.
Sir, one more question. There was
Yeah,
one question in our assignment to deploy Python web applications developed using the Flask framework. Do we need to write
yeah.
the code also, or just steps we need to?
But without writing code, how you will deploy it?
It's developed using the Flask framework and deployed as a container using the AWS platform.
Hmm.
Okay, got it.
Right. So, I think you can defer that question if you would like to practically handle it, because next session I'm planning that the basic AWS Academy thing, the accounts you are having, so how to
Yeah.
utilize that. So after that you can answer it more precisely. Okay.
Okay, but we have to submit this assignment. before that?
No, no, not before that. What's
It's
the last date?
18. I don't know.
No, no, no. I never keep Saturday as the final date.
21st I'm seeing in that
Yeah, yeah,
assignment, right, sir?
yeah.
Okay.
21st. Okay.
Never set Saturday or Sunday as the last date because I understand your situation, right?
Okay.
So
Then
that
yeah.
way
Then
it
I will.
will be,
I was
yeah,
just going through and I saw these
yeah.
questions.
You can
Okay.
keep the skeleton ready, and once you do the experiment, after that you can attach rest of the screenshots. I think that way it can be done.
Okay. Okay.
Yeah.
Thank you, sir.
Okay. Thank you. I'm ending with the call.
Thank you, sir.